Hello and welcome to Msit 5450, Section 31, Designing and Building a Cybersecurity Program. My name is Larry Wilson. I'm the instructor. And this week, week 14, we will be discussing the Cybersecurity Maturity Model Certification, or CMMC. Here's the course outline. Week 1 was course introduction and scope. Week 2, 3, 4, business risk requirements, engineering design requirements, technology operations requirements. Week 5, 6, 7, business risk workloads, engineering design workloads, technology operations workloads. Week 8, 9, 10, business risk deliverables, engineering design deliverables, technology operations deliverables. Week 11, we discussed the MITRE attack framework. Week 12, the SOAR security operations framework. Week 13, the application security framework. And this week, week 14, the CMMC framework, which is the Cybersecurity Maturity Model Certification Framework. And next week, week 15, will be the last week, course review and summary. Today's agenda, we have 4 parts. Part 1, protecting Department of Defense controlled unclassified information, or CUI. Part 2, the 3-step process for complying with DFARS requirements. Part 3, NIST 800-171 security requirements, and Part 4, the Cybersecurity Maturity Model Certification, or CMMC. Learning objectives: 1, understand DoD controlled unclassified information. 2, understand the 3-step process for complying with DFARS requirements. Objective 3 is to understand NIST 800-171 security requirements. And 4, understand the CMMC model certification. So part 1 is protecting DoD controlled unclassified information. Subcontractors on a Department of Defense contract likely have a flow down requirements from their prime contractors related to DFARS, which is the DoD Federal Acquisition Requisition System, Clause 252.204-7012, which is called NIST 800-171. Many subcontractors, as they scramble to secure their infrastructure to be in compliance before the December 2017 DFARS deadline, are also asking, when should DFARS Clause 252.204-7012 flow down to the subcontractors? And to help answer that question, there are some basic related to DFARS Clause 7012, safeguarding covered defense information, and cyber incident reporting, which was effective October 21st, 2016, and the details are in NIST 800-171. So DFARS Clause 252.204-7012 requires contractors and subcontractors to safeguard covered defense information that is resident on or transiting through a contractor's internal information system or network. 2, report cyber incidents that affect the covered contractor's information system or the covered defense information residing therein, or that affect the contractor's ability to perform requirements designated as operationally critical support. Number 3, submit malicious software discovered and isolated in conjunction with a reported cyber incident to the DoD Cybercrime Center. And 4, if requested, submit media and additional information to support damage assessment. So DFARS Clause 252.204-7012 is for covered defense information, which is unclassified controlled technical information, or other information as described in the Controlled Unclassified Information Registry that requires safeguarding or dissemination controls and is either marked or otherwise identified in the contract, task order, or delivery order and provided the contractor on behalf of DoD in support of the performance contract of the contract, or is collected, developed, received, transmitted, used, or stored by or on behalf of the contractor in support of the performance of the contract. The clause impacts subcontractors when performance will involve operationally critical support or controlled CDI. And organizations should determine in consultation with their contracting officer if the information required for subcontract performance is or relates as CDI and requires safeguarding or dissemination controls. Flow down is enforced by the prime contractor, so that's important. The flow down clause of DFARS 252.204-7012 is enforced by the prime contractor. And if a subcontractor does not agree to comply with the clause, CDI should not be on that subcontractor's information systems. Contractor compliance. By signing the contract, the contractor agrees to comply with the terms of the contract and all requirements of the DFARS clause 252.204/7012. The DFARS rule did not require any unique or additional requirements for the government to monitor contractor implementation of required security requirements. DoD will not certify that a contractor is compliant with NIST 800 and 171 security requirements. Third-party assessments or certifications of compliance are not required, not authorized, or recognized by DoD. If oversight related to these requirements is deemed necessary, it can be accomplished through existing FAR and DFARS allowances, or an additional requirement can be added to the terms of the contract. So what is the NIST 800-171 standard? It enables contractors to comply using systems and practices likely already in place, significantly reduces unnecessary specificity as requirements are performance-based and more easily applied to existing systems, provides standardized uniform set of requirements for all CUI security needs, and again, CUI is controlled unclassified information from the government, allows non-federal organizations to consistently implement safeguards for the protection of CUI, and allows contractors to implement alternative but equally effective security measures to satisfy CUI security requirements. These are the NIST 800-171 control families, and these are derived from NIST 853. There are 14 control families. The first is access control. The second is awareness and training, audit and accountability, configuration management, identification and authentication, incident response, maintenance, media protection, physical protection, personnel security, risk assessment, security assessment, systems communications protection, and systems and information integrity. Meeting NIST 800-171 security requirements. Most requirements are about policy, process, and configuring IT securely, but some may require security-related hardware or software. For companies new to the requirements, a reasonable approach would be, number one, examine each of the requirements to determine policy or process. Policy process requirements that require an implementation in IT, typically by either configuring the IT in a certain way or through the use of specific software. IT configuration requirements, and any additional software or hardware required. The complexity of the company IT system may determine whether additional software or tools are needed. Determine which of the requirements can readily be accomplished by in-house personnel and which require additional research or assistance, and develop plans of action to implement the requirements. Demonstrating the implementation of NIST 800-171. And these are all part of NIST 800-171 requirements. First, when requested, the system security plan and the associated plans of action for any planned implementation or mitigation should be submitted to the responsible federal agency contracting officer to determine the non-federal organization's implementation or planned implementation of the security requirements. Requirement 3.12.4, develop, document, and periodically update a system security plan that describes the system boundaries, system environment of operation, how security requirements are implemented, and the relationships with or connections to other systems. Requirement 3.12.2 is to develop and implement plan of action designed to correct deficiencies, reduce or eliminate vulnerabilities in organizational systems. The system security plan may also be used to document and describe situations where requirements cannot be practically met or non-applicable. Alternative but equally effective security measures approved by DoD CIO. Situations where specialized systems such as medical devices, computer numeric control, or other shop floor equipment cannot by their nature meet the NIST 800-171 requirements. Situations when the contractor's policy process does not allow the circumstances addressed in the security requirements. For example, requirement 3.1.12 states the remote access must be monitored and controlled, but the organization does not allow and positively presents by technical or procedural means any remote access. And requirement 3.1.18 requires controlling the connection of mobile devices. The organization does not allow such connections and ensures such connections are not provisioned. Individual isolated or temporary deficiencies addressed by assessing risk and applying mitigations. So the following are the steps for the pre-assessment. Preparing for a self-assessment. Number one, preparatory activities address issues relating to the costs, schedule, performance of the assessment. So preparing for a security control assessment includes: one, ensure the security policies are in place and understood by company employees; two, establish the objective and the scope of the assessment; three, notify key employees of assessment activities; four, allocate resources to conduct the assessment; five, establish communication channels among the employees having an interest in the assessment; six, establish timeframes for completing the assessment; seven, select the assessment teams that will be responsible for conducting the assessment; and eight, collect materials to provide the assessor's assessment teams. This may include policies, procedures, plans, specifications, designs, records, administrator operating manuals, information system documentation, interconnection agreements, previous assessment results, and legal requirements. And here is a checkbook or a checklist of things that you want to do when preparing for an assessment. First, you want to look at your plans, such as business continuity, contingency, continuity of operations, critical infrastructure, crisis communication, disaster recovery, incident response testing, occupant emergency plan, physical environmental protection, plan of action, security assessment, security plan, and system security plan, as well as policies, access control, audit and accountability, configuration management, configuration planning, incident response, identification, authentication, information flow control, information flow enforcement, information system maintenance, media protection, media sanitization and disposal, mobile code implementation, password, personnel security, physical and environmental protection, portable media, risk assessment, security assessment authorization, security awareness and training, security planning, separation of duties, system and information integrity, system and services acquisition, system and communications protection, and system use. And conducting a self-assessment based on NIST 800-171 Revision 1 security controls. NIST 800-171 assumes that small manufacturers currently have IT infrastructure in place, and it's not necessary to develop or acquire new systems to handle controlled unclassified information. Most small manufacturers have security measures to protect their information, which may also satisfy the 800-171 requirements. A variety of potential security solutions can be implemented to satisfy the requirements. Small manufacturers may not have the necessary organizational structure or resources to satisfy every security requirement. It's perfectly acceptable to implement alternative but equally effective security measures to satisfy a requirement. Conducting security control assessments can be challenging and resource intensive. Successful assessments require cooperation throughout the company. Establishing expectations before, during, and after an assessment is important to achieve an acceptable outcome. Though preparation is an important aspect of conducting effective security control assessments. Security control assessors, assessment teams begin the assessment by gaining an understanding of the company's operations, including mission, functions, business process, how the information system supports those functions. Obtaining an understanding of the structure of the information system, such as system architecture. Identifying company personnel responsible for the development and implementation of security requirements. Meeting with company personnel to ensure understanding for the assessment objectives, the rigor, the scope of the assessment. Obtaining assessment materials such as policies, procedures, plans, specifications, designs, records, administrator and operator manuals, information system documentation, interconnection agreements, previous assessment results. Establishing company points of contact needed to carry out the assessment. Obtaining previous assessment results that can be reused, such as audits, vulnerability scans, physical security inspections, prior security assessments, development, testing, and evaluation, vendor flow, remediation activities, and developing an assessment plan. Assessment results. For each security requirement question that the company answers yes, a statement should be included in the security assessment report and system security plan that explains how the information system implements the requirement. For each security requirement that has the answer of no, a statement should be included in the security assessment report which explains why the security requirement is not met. A statement should also be included in the plan of action which fully describes how the unimplemented security requirements will be met and any planned improvements will be implemented and when the improvements will occur. For each security requirement questions that the company answers partial, a statement should be included in the security assessment report, which explains why a security requirement is partially met. A statement should also be included in the plan of action, which fully describes how the partially met security requirements will be fully met and how any planned improvements will be implemented and when the improvements will occur. And finally, for each security requirement question the company answers does not apply, a statement should be included in the security assessment report, which explains why the security requirement does not apply to your operational environment. And here's a list of resources to help do a NIST 800-171 assessment. We have the NIST Manufacturing Partnership, which is MEP. NIST Manufacturing Extension Partnership is available at nist.gov/MEP. We have the Manufacturing Extension Partnership Handbook 162, which helps determine a handbook for assessing NIST 800-171 security requirements. We have Procurement Technical Assistance Program, or PTAP, and Procurement Technical Assistance Centers, or PTACs. We have the, again, where the PTAP is located. We have the Cybersecurity Evaluation Tool, or CSET, which is a no-cost application developed by Homeland Security's Industrial Control Systems and Cybersecurity Emergency Response Team. It provides step-by-step process to evaluate industrial control system, information technology, network security practices. The CSET tool, where you can download that tool, as well as NIST 800-171A, which is assessing security requirements for controlled and unclassified information. Okay, so that describes DFARS and the requirements for NIST 800-171. Now let's talk about what is a three-step process to comply with DFARS. Step 1, develop a system security plan. Step 2, conduct an assessment, produce security assessment report. And step 3 is produce a plan of action. So step 1, develop a system security plan. This describes what an IT system looks like, who the key people are, what security level the system warrants, what controls need to be addressed, which are based on NIST 800-171 Revision 1, how and by whom the controls are implemented, and what the status of a given control is. Step 2, you conduct the assessment. Here we develop an assessment plan, conduct the assessment against security requirements in NIST 800-171, either conduct a self-assessment or a third-party assessment. Determine if security requirements are effective and operating as intended, and some requirements may not apply, alternative but equally effective. Produce a security assessment report, and there's no particular format. And then step 3 is a plan of action and milestones, which describes how any unimplemented security requirements will be met, how any planned improvements will be implemented, a detailed milestones used to measure progress, and no deadline for meeting the plan of action items. Submitting to DoD contracting officer or prime contractor. So if you're a subcontractor, these are the 3 documents that you will have to submit to your DoD contracting officer. They include the system security plan, security assessment report, and the plan of action. Important things to remember regarding compliance with DFARS cybersecurity requirements. Compliance occurs upon approval of the system security plan, the security assessment report, and the plan of action. Approval of these items comes from the appropriate DoD contracting officer or prime contractor, depending on when a particular manufacturer falls within the supply chain. Some plans may need to be reviewed by the DoD CIO. Contractor's signature on a contract indicates that DFARS cybersecurity requirements have been met. That's really important. So if the contractor is going to sign off that the DFAR requirements are met, that means the contractor will have had to have seen the system security plan, the security assessment report, and the plan of action. No predetermined audit processes are planned, but audits by DoD may occur as warranted. So even though there are no official timing or scheduling for for audits, the DoD can conduct an audit whenever they feel like it's important. So let's walk through these 14 control families of NIST 800-171, starting with access control. So the access control family really focuses on the ability to make use of any system resource. Access control is a process of granting or denying requests to use information processing services, or enter company facilities. Logical access control prescribe who or what can access system resource and the type of access is permitted. Built into the operating system or incorporated into application programs or major utilities such as database management systems, communication systems, or implemented through add-on security packages, and may be implemented internally to the system or in external devices. Companies should limit system access to authorized users, limit processes acting on behalf of authorized users, limit devices, including other systems, and limit the types of transactions and functions that authorized users are permitted to exercise. It may also be important to control the kind of access permitted, such as the ability for the average user to execute but not change system programs. These types of access restrictions enforce policy and help ensure that unauthorized actions are not taken. Controlling physical access to company facilities is also important. It provides better protection for employees, plant equipment, hardware, software, networks, and data from physical actions and events that could cause serious loss or damage to the company. The next family is awareness and training. Information security awareness, training, and education raises awareness about the need to protect system resources. It develops skills and knowledge so system users can perform their job more securely, and it builds in-depth knowledge as needed to design, implement, operate security programs for organizations and systems. All managers and users are aware of the security risks associated with their activities, and employees are trained to carry out their information security related duties and responsibilities. The third family is audit and accountability. Audit and independent review and examination of records and activities, assess the adequacy of system requirements, ensure compliance with established policies and procedures. An audit trail is a record of who has accessed the system, what operations were performed during a given period, maintains a record of system activity, detects security violations, performance issues, flaws in applications, ensures the system has not been harmed by hackers, insiders, or technical problems. It's an insurance policy maintained but not used unless needed, such as after an outage. We want to create, protect, and retain system audit records, enables monitoring, analysis, investigation, and reporting of unlawful, unauthorized, inappropriate system activity. Actions of users can be uniquely traced and users can be held accountable. The fourth family is configuration management, determining and documenting the appropriate specific settings for a system, conducting security impact analysis, managing changes through a change control board, allows the entire system to be reviewed, helps ensure a change made on a system does not have an adverse effect on another. Common secure configuration, security configuration checklists, provide recognized, standardized, and established benchmarks, specify secure configuration settings for information technology platforms and products, can be used to verify that changes to the system have been reviewed from a security point of view. Helps determine if major changes such as connecting to the internet have occurred or they have not yet been analyzed. And the NIST checklist repository or the National Vulnerability Database is where you can review some of this information. Family 5 is identification authentication, verifying the identity of a user, process, or device, prerequisite for granting access to a resource in a system, prevents unauthorized individuals or processes from entering a system. It's the basis for most types of access control and user accountability. Identify and differentiate between users. User accountability requires linking activities on a system to specific individuals. Authentication presents several challenges: collecting authentication data, transmitting the data securely, and knowing whether the individual who was originally authenticated is still the individual using the system. User identity can be authenticated based on something you know, such as a password or a PIN, something you possess, a token, such as an ATM card or a smart card, something you are, biometric, such as a fingerprint, retina, face, ear, or DNA, and something you do, which is dynamic biometrics, a voice pattern, handwriting, or typing rhythm. Family 6, incident response. Standard operating procedures that can be followed in the event of an incident, addresses in a company's contingency plan. Threat events can also result from a virus, other malicious code, or a system intruder, either insider or outsider. Definition of a threat event is somewhat flexible and may vary by company and computing environment. Recurrence of similar incidents can make it cost beneficial to develop a standard capability for quick discovery of and response. closely related to contingency planning. Respond to malicious technical threats. Incident handling capability includes adequate preparation, detection, analysis, containment, recovery, user response, and track, document, and report incidents to company management. Maintenance family. Control maintenance, scheduled and performed in accordance with the manufacturer's specification. Corrective maintenance, when a system fails or generates an error condition that must be corrected. Performed locally or non-locally. Non-local maintenance is maintenance or diagnostics performed via network, internal or external. Perform periodic and timely maintenance on company systems. Provide effective controls on the tools, techniques, mechanisms, and personnel used to conduct system maintenance. Media protection. Defense of system media, both digital and non-digital. Digital media diskettes, magnetic tapes, external removable hard drives, flash drives, compact discs, and digital video sticks. Non-digital media is paper on microfilm. Restrict access. Media is only available to authorized personnel. Any security labels to sensitive information. Remove information from media so the information that cannot be retrieved or reconstructed. Physical security control system media and ensure accountability. Restricting mobile devices capable of storing and carrying information into or outside restricted areas. Destroy system media before disposal or reuse. Personnel security. Users play a vital role in protecting a system. Personnel security seeks to minimize the risk that permanent, temporary, or contractor staff pose to a company asset. Company status and reputation can be damaged by the action of employees. Employees may have access to extremely sensitive proprietary information. Recruiting and hiring new employees, employee transfers, or is terminated. Consequences for failing to comply with company security policies and procedures. Physical protection. Protection of systems, buildings, related support infrastructure from natural threats, man-made threats. Here we want to limit physical access to systems, networks, and operating environments, protect the physical plant and support infrastructure, provide backup support, protect systems against environmental hazards, and provide appropriate environmental controls in facilities. Risk assessment family. Risk assessments identify and prioritize risks to company operations, assets, employees, and other organizations. Risk assessment identify relevant threats or threats directed against other organizations, vulnerabilities, both internal and external, impacts such as harm that may occur if threat exploits vulnerabilities, and the likelihood that that harm will occur, and we want to periodically assess risk. Security assessment family. Testing or evaluation of the management, operational, technical security requirements, determine if the requirements are implemented correctly, operating as intended, producing a desired outcome with respect to meeting the security requirements for the system, most effective and cost-efficient solution. Continuous basis to support a near real-time analysis of a security posture. Company makes a decision to operate for a new system or continue to operate. Document actions in the system security plan. System and communications protection family. Confidentiality of information at rest and in transit. Physical logical means. Establishes boundaries that restrict access to publicly accessible information within a system. Monitor and control communications at external boundaries and key internal boundaries within the system. Employ architectural design, software development techniques, and systems engineering principles. System and information integrity. Guarding against improper information modification or destruction. Data can only be accessed by modified by the authorized employees. Assurance that information being accessed has not been meddled with or damaged by an error in the system. Companies should identify, report, correct information and system flaws in a timely manner. Provide protection from malicious code at appropriate locations within company systems. Monitor security alerts and advisories and respond appropriately. Meeting NIST 800-171. Emphasis is risk management for a particular operating environment. Some security controls may not be applicable to your environment, such as remote access, the example used earlier. You want to build off what you're currently doing. Security controls are intended to be flexible. Other ways to meet the requirements, implement alternative but equally effective security measures, and cost-effective approaches. Isolate CUI's own security domain by applying architectural design concepts. Security domains may employ physical separation, logical separation, or a combination of both. Use the same CUI infrastructure for multiple government contracts or agreements. So part 4, we're going to now move forward from NIST 800-171 to the CMMC, or the Cybersecurity Maturity Model Certification. And this was been ongoing over the last couple of years. This particular set of requirements has really been out since January of this year. CMMC is a unified cybersecurity standard for the future DoD acquisitions. CMMC model version 1 encompasses the following: 17 capability domains and 43 capabilities. And we just discussed the 14 domains of NIST 800-171. Now that we have 17 domains, 43 capabilities, 5 processes across 5 levels to measure process maturity, 171 practices across 5 levels to measure technical capabilities. So here we see 5 different levels of CMMC. We see the number of practices from 17 for level 1, and they're additive. Level 2 would be 72, level 3 would be 130, level 4 would be 156, level 5 would be 170. And then for processes, we would not have any for level 1, we'd have 2 for level 2, 3 for level 3, 4 for level 4, and 5 for level 5. So the CMMC model, we start with the model itself, and then we have domains, again 17 domains. And then we have a number of processes. For each given domain, there are processes that span the subset of the 5 levels. We also have capabilities. For each given domain, there are 1 or more capabilities that span a subset of 5 levels. And then for each capability, there are 1 or more practices that span the subset of the 5 levels. CMMC model framework organizes processes and best practices into a set of domains. Process maturity or process institutionalization characterizes the extent to which an activity is embedded or ingrained in the operation of an organization. The more deeply ingrained an activity, the more likely is that the organization will continue to perform the activity, including under times of stress. The outcomes will be consistent, repeatable, and of high quality. Practices or activities performed at each level of the domain. So these are the 17 domains, starting with access control, asset management, awareness and training, audit and accountability, configuration management, identification authentication, incident response, maintenance, media protection, personnel security, physical protection, recovery, risk management, security assessment, situational awareness, system communications protection, and system and information integrity. So the 3 new domains would be asset management, recovery, and situational awareness. So we take the 14 prior domains and add those 3, and those are the 17 domains for CMMC. Each of these are measured with 5 levels of maturity. So for processes, maturity would range from level 1 of performed, level 2 documented, level 3 managed, level 4 reviewed, level 5 optimized. And for practices, level 1 is basic cyber hygiene, level 2 is intermediate cyber hygiene, level 3 is good cyber hygiene, level 4 is proactive, and level 5 is advanced and progressive. So here's some examples of maturity of processes from level 1 to level 5. Again, level 1 is performed. 0 processes. Select practices are documented where required. Level 2, which is documented, has 2 processes. Each practice is documented, including level 1 practices, and a policy exists that includes all activities. Level 3, which is managed, has 3 processes, which are, again, the same 2 processes as level 2 plus an additional one. Each practice is documented, including lower levels. A policy exists that covers all activities, and the new process, a plan exists, is maintained and resourced that includes all activities. Here, the planning activities may include mission, goals, project plan, resource training needed, and involvement of relevant stakeholders. So at level 4, we have 4 processes. Again, 3 from level 3, which is each practice is documented, including lower levels. A policy exists that covers all activities. A plan exists that includes all activities. And then the 4th process is activities reviewed and measured for effectiveness. Results of the review is shared with higher level management. And then the next level, level 5, is called optimizing. Here we have 5 processes, again 4 from level 4 and 1 additional process. The 4 level 4 processes, each practice is documented, including lower levels. Policy exists that covers all activities. A plan exists that includes all activities. Activities are reviewed and measured for effectiveness. And then we've added a 5th process. There's a standardized documented approach across all applicable organizational units. And the 5 practices. At level 1, we actually have 17 practices, equivalent to all practices in Federal Acquisition Regulation, or FAR 48 CFR 52.204-21. Under level 2, we have 72 practices. Number 1, comply with the 17 practices of the FAR. Next, we select a subset of 48 practices from NIST 800-171 and includes an additional 7 practices to support intermediate cyber hygiene. Practices for level 3 are 130. Comply with the FAR, encompass all practices from NIST 800-171. So all practices will be 110 of those. And then finally includes an additional 20 to make 130 practices to support good cyber hygiene. So level 3 is pretty much where we were talking about NIST 871 with the addition of 20 practices. Level 4 is called proactive. Here we have 156 practices, comply with the FAR, and encompass all NIST 800-171 practices, which again were 110. Includes a select subset of 11 practices from NIST 171B, and then includes an additional 15 practices to demonstrate a proactive cybersecurity program, for a total of 156 practices. And then finally, level 5 is 171 practices, comply with the FAR, encompass NIST 800-171, includes a select subset of 4 practices from 171B, includes an additional 11 practices to demonstrate an advanced cybersecurity program, or 171 overall practices. So that's how the practice progression is on the CMMC. So we've talked about both process progression and practice progression. And these are an overview of the 17 CMMC domains. The first one is access control. The capabilities to establish system access requirements, control internal system access, control remote system access, limit data access to authorized users and processes. The second one is asset management, identify and document assets. Third one is audit and accountability, define audit requirements, perform auditing, identify and protect audit information, and review and manage audit logs. The fourth is awareness and training, conduct security awareness activities and conduct training. Next, we have configuration management, establish configuration baselines, perform configuration and change management. Next, identification authentication, grant access to authenticated entities. Incident response, plan the incident response, direct and report events, develop and implement a response to a declarative incident, perform post-incident reviews, and test incident response. And then finally, maintenance, where we manage maintenance. Media protection, identify and mark media, protect and control media, sanitize media, protect media during transport. For the personnel security domain, we screen personnel and conduct CUI during personnel actions, or protect CUI during personnel actions. For the physical protection domain, we have limit physical access. For the recovery domain, manage backups. For the risk management domain, identify and evaluate risk and manage risk. For the security assessment domain, develop and manage a security plan, define and manage controls, perform code reviews. Situational awareness domain, implement threat monitoring. System communications protection domain defines security requirements for systems communications, control communications at system boundaries. And for the system and information integrity domain, identify and manage information system flaws, identify malicious content, perform network and system monitoring, implement advanced email protections. So this shows the number of practices by domain for the different levels, level 1 maturity, all the way through level 5 maturity. So, for example, level 5 maturity under access control is 26 practices. Level 5 maturity for asset management is 2 practices. Level 5 maturity under audit and accountability is 14 practices, etc. Level 5 maturity overall, again, is 171 practices. So this is again the breakdown of practices per level. Level 1, again, 17 practices. Level 2, we add 55 to the 17 for 72 practices. Level 3, we add 58 to the 72 for 130 practices. Level 4, we add 26 to the 130 for 156 practices. And level 5, we add 15 to the 156 for 171 practices. So the source counts. Model leverages multiple sources and references. CMMC Level 1 only addresses practices from the FAR Clause 52.204-21. Level 3 includes the practices from NIST 800-171 as well as others. And levels 4 and 5 incorporate a subset of the practices from the NIST 800-171B plus others, as well as additional sources such as the UK Cyber Essentials and Australia's Cyber Security Center Essential 8 Maturity Model were also considered a reference in the model. So here's again another way of looking at the practices per source. Level 1, we have 17 practices, NIST 800-171. Level 2, we had an additional 55. 48 of those are for NIST 800-171, 7 are for other. Level 3, 58, 45 from NIST 800-171, 13 from other. Level 4, we have 26 additional, 11 from 800-171B, 15 from other. And level 5, we have 15 additional for a total of 171. An additional from 4 from 171B and 11 from other gives you the total number of practices for each of the 5 levels. CMMC, in summary, establishes cybersecurity as a foundation for future DoD acquisitions. CMC levels align with the following focus. Level 1 is basic. Level 2 is transition step up to protect controlled and classified information. Level 3, protecting CUI. Level 4 through 5, protecting CUI and reducing risks of advanced persistent threats. Four steps to becoming CMMC certified. Number 1, ensure compliance with NIST 800-171. Start by ensuring your company's compliance with NIST 800-171. It's a set of CMMC cybersecurity control requirements for protecting controlled unclassified information. Government publications like NIST 800-171 share similarities with CMMC mandates in maintaining security controls. And this means that compliance with NIST 800-171 puts you one step closer to CMMC compliance. 2, align your timelines with the CMMC cybersecurity. And starting this past year in January, CMMC information is released. CMMC levels, requirements for every level, independent CMMC certifiers and third-party assessment organization training materials were put in place. February through May, assessors undergo CMMC certification training, perform assessments, understand the requirements for CMMC maturity levels. June through September, contractors' request for proposal and request for information are approved based on their CMMC certification. During this period, only a certain number of contractors will be selected for the initial CMMC audits. And starting in October or last month, from this point onward, holding the appropriate CMMC maturity level certification will determine the contractors and subcontractors' eligibility to be approved for DoD contracts. Step 3 is to familiarize yourself with third-party assessment organizations, or 3PAOs. Your CMMC maturity needs to be signed off by a third-party assessment organization, which are organizations qualified to perform security assessments on cloud-based systems. Although you may conduct your own internal assessment, implement security controls that align with CMMC standards, which is a good idea to get prepared, 3PAO will still need to be involved in the compliance process. It's essential to become familiar with these assessors, as they will evaluate your target maturities level of condition, and many of them also assess contractors for NIST compliance. In some cases, the DoD may conduct assessments for high-level CMMC certifications. If you fall into this assessment category, coordinate with assessors from the Defense Contract Management Agency, or DCMA, or the Defense Counterintelligence and Security Agency, DCSA. And then finally, Level 4, identify step 4, identify the level of CMMC cybersecurity compliance for your organization. And again, there are 5 levels. Level 1 is basic. There's no requirement to document security process, and it is the easiest level to achieve. Level 2 is intermediate. Security processes must be processed and documented. Level 3 is good cyber hygiene. Most contractors aim to achieve this level since this is the medium level that allows companies to handle CUI. Or I'm sorry, the minimum level to handle CUI is level 3. Level 4 is proactive cyber hygiene. Achieving this level requires meeting the requirements from level 1 through 3 and additional cybersecurity measures. And then finally, level 5, advanced and progressive cyber hygiene. The highest level certification requires the demonstration of sophisticated security capabilities to safeguard CUI from advanced persistent threats. And here is, again, a diagram that shows the CMMC timeline. Starting in January, release of CMMC levels, requirements, third-party assessor training materials. February through May, CMMC assessors train on the requirements for all CMMC maturity levels. June through September, RFP and RFI are approved based on the maturity level of certification. And then October onward, CMMC maturity level certification determines eligibility for a DoD contract. So that describes the CMMC process, which is really an evolution that started with NIST 800-171, and compliance with NIST 800-171 essentially says that you're at level 3 maturity and that you can protect controlled unclassified information. But going forward, we're going to be looking for more CMMC assessments done by third-party assessment organizations. So if you have any questions on CMMC, NIST 800-171, please make sure that you post those in the discussion board. Thank you.